In the UPSC Civil Services (IAS) Main Chemistry Optional Exam, Paper I, Solid-State Chemistry is a highly scoring and structured section. Questions generally fall into three categories: crystal structures, mathematical derivations, Bragg's law, Miller indices, and crystal defects. Below is a selection of high-yield, past-year style questions with model answers formatted to meet UPSC evaluation standards, requiring clear assumptions, mathematical precision, and neat representations. Question 1. Crystal structure derivation, 10 marks. Account for the structure of sodium chloride, sodium chloride. Calculate the number of formula units per unit cell and explain its coordination geometry. Answer. 1. Structural arrangements. The sodium chloride, rock salt, structure is an ionic lattice that can be described as follows: anion framework, Cl icons form a face-centered cubic, FCC, cubic close-packed, CCP, lattice array. Cation placement. Na plus icons occupy all the octahedral voids of the lattice. 2. Calculation of formula units per unit cell, Z, number of Cl icons. Number of Na plus icons. Since there are 4 Na plus icons and 4 Cl icons, the total number of formula units per unit cell is Z equals 4. 3. Coordination number and geometry. Each Na plus ion is directly surrounded by 6 Cl icons at the corners of a regular octahedron. Conversely, each Cl ion is surrounded by 6 Na plus icons. Therefore, the crystal exhibits a 6:6 coordination geometry. Question 2. X-ray diffraction and Bragg's law, 15 marks. A. Derive Bragg's equation for X-ray diffraction by crystals. B. First-order reflection from a crystal plane occurs at an angle of 11.8 circ using X-rays of wavelength 1.54. Text A. Calculate the interplanar spacing, D. Answer. A. Derivation of Bragg's law. Let a beam of monochromatic X-rays with wavelength lambda strike a set of parallel crystal planes separated by an interplanar distance d at an incident angle, theta. Consider two parallel rays reflecting off two adjacent atomic layers. The extra path length traveled by the second ray relative to the first ray is given by the segments CB plus BD. From right-angle trigonometry in triangle ABC and triangle ABD. Therefore, the total path difference, delta, is. For constrictive interference, to produce a bright diffraction peak, this path difference must be an integral multiple of the wavelength, n, lambda. Where n equals 1, 2, 3, dots represents the order of reflection. B. Numerical problem. Given data, order of reflection, n equals 1. Wavelength, lambda equals 1.54, text A, equals 1.54, times 10 minus 10, text M. Bragg angle, theta equals 11.8 circ, implies sin, 11.8 circ, approx 0.2045. Calculation, using Bragg's equation. Answer. The interplanar spacing, D, is 3.77, text A. Question 3. Crystal defects, 10 marks. Differentiate clearly between Schottky and Frenkel defects. Discuss their effect on the density and electrical conductivity of a solid. Answer. These are intrinsic stoichiometric point defects that arise due to thermal variations in ionic solids. Property. Schottky defect. Frenkel defect. Basic nature. A pair of vacancy defects caused by missing equal numbers of cations and anions from their regular lattice sites. A dislocation defect where an ion, usually the smaller cation, leaves its lattice site and occupies an interstitial position. Structural prerequisite. Favored by compounds with high coordination numbers and small differences in cation-anion sizes. Favored by compounds with low coordination numbers and a large size difference between icons. Effect on density. Decreases the overall density of the crystal because mass decreases while volume remains constant. Unchanged. The mass and volume of the unit cell remain exactly the same. Examples. Sodium chloride, KCl, cesium chloride. AgCl, silver 1 bromide, ZnS. Effect on electrical conductivity. For both defects, the electrical conductivity increases. In Schottky defects, the migration of ions into neighboring vacant lattice holes creates a cascade of vacancy movements. In Frenkel defects, the mobility of the interstitial ions through the empty interstitial channels serves as charge carriers under an applied electric field. Question 4. Band theory and non-stoichiometry, 15 marks. Explain the mechanism of semiconduction in N-type and P-type semiconductors using band theory. How does a non-stoichiometric compound like ZNO exhibit enhanced conductivity upon heating? Answer. 1. Mechanisms using band theory. According to band theory, solids possess a valence band, VB, filled with electrons and an empty conduction band, Cb, separated by a band gap, E_G. N-type semiconductors, prepared by doping a semiconductor with a pentavalent impurity, e.g., C doped with P. The extra valence electron occupies a discrete donor energy level located just below the conduction band. Thermal energy easily excites these electrons into the Cb, allowing conduction via negative electrons. P-type semiconductors, prepared by doping with a trivalent impurity, e.g., C doped with B. This creates an empty acceptor energy level just above the valence band. Electrons from the Vb jump into this acceptor level, leaving behind positive holes in the Vb that mediate electrical conduction. 2. Non-stoichiometry in zinc oxide, ZNO. Zinc oxide is a white stoichiometric oxide at room temperature. Upon heating, it loses oxygen reversibly according to the reaction mechanism. The escaped oxygen leaves behind excess zinc 2+ ions and free electrons. These excess zinc 2+ ions migrate into the interstitial spaces of the crystal lattice, while the liberated electrons trap themselves in nearby interstitial positions to maintain electrical neutrality. Conduction and color. The free electrons can easily be excited into the conduction band, changing ZNO into an interstitial excess N-type semiconductor. These trapped electrons undergo D to D transitions or plasmon excitations, causing the color to turn from white to yellow when hot. To refine your IS mains preparation for chemistry paper I, select a direction below, practice numerical problems on density calculation. Derive interplanar distance formula.